An actuary models the lifetime of a device using the random variable y equals 10x power 0.8, where x is an exponential variable with mean 1. Let fy be the density of the function y. Find fy. So first we need to figure out what what the density function for x looks like. So eventually we need y, and you can get y whether you know the PDF or the CDF of x, but if you know the CDF, that's actually easier. And we know that CDF for an exponential variable with mean k is 1 minus e to the negative kx. And usually we call the CDF as capital F, but in this case, capital F will be this CDF for this little f, which is another function given. So therefore, we use a different symbol. So the CDF of exponential is 1 minus e to the negative kx, but we know that the mean is 1, they tell us. And so it would be 1 minus e to the negative x. And then we need the CDF of y. And we've discovered by now that whenever it's a transformation problem, in order to, we need the PDF of y. And we know that if it's a transformation problem, even if you have to get the PDF, you have to go through the CDF. So we first go for the big F of y. So the big F of y is the probability big Y is less than or equal to little y, and big Y is 10x power 0.8, that's given. And so that's less than or equal to little y, and then you divide by 10, you get 0.1 y, and then you raise both sides to the power 1 over 0.8, and 1 over 0.8 is 1.25. So its probability big X is less than or equal to this quantity, and that is the definition of the CDF. And the CDF of X was G, so that means it's G of this quantity, and G of X is 1 minus e to the negative X. So G of this quantity would be 1 minus e to the negative this quantity. And that was the big F, and the little f is the derivative of the big F. So the derivative of 1 is 0, and then we have negative. And then, the derivative of the exponential function is itself. And then by chain rule, we need the derivative of the power of the exponential function. So the derivative of this power, we use the power rule in that. So be negative 1.25, so negative 1.25, and then the base, and then you reduce the power by 1, so 1.25 minus 1 is 0.25, and then we still need another level of chain rule because the base was not just a y, but it was 0.1 y, so the derivative of 0.1 y is 0.1. And then the two negatives cancel out, one from here and one from here. And the 1.25 gets multiplied with 0.1 to give 0.125. And then we have this 0.1 y power 0.25, and then the exponential function, the last one. And we recognize that this is choice E, 0.125, 0.1 y to the 0.25. And they write it as exp of all this, but that's the same thing as e power of all this. So it's choice E.